All right, guys, so now that we've got a basic understanding of what some of these three-dimensional solids are called, which we did in 11.4a, now we're going to move on into what we're really trying to accomplish in 11.4, which is finding the surface area of prisms and cylinders. Now, if you've ever wrapped a present before, which I would hope most of you guys have, you've got a sense for what surface area means. If you think about how much wrapping paper it takes to cover up a box, you're trying to take something flat and two-dimensional, that would be the wrapping paper, and cover something three-dimensional with it. So that's essentially what we're trying to measure with surface area. What is the area of all of the individual faces put together? So we're going to start off here, guys, with the formula for surface area of a prism. And that formula is this one, 2b plus capital P times H. And I should have said 2 times capital B. Now, guys, I've said many, many times, I'll continue to say, a formula is no good to you unless you know what everything stands for. So we really need to break this down. And the first most important thing here is that this is not a lowercase b, it's a capital B. Now, we used a lot of lowercase b's in the previous chapter, and lowercase b always stood for a base, which was usually then, pretty much always, not usually, a length. The base of this rectangle is 7 centimeters long. But now what we're talking about here is capital B, and capital B means area of a base. So if you go back to your definitions right there from 11.4a, a prism, and I've got 3 examples of them here, is a three-dimensional solid made up of 2 congruent and parallel polygon bases on opposite ends of the figure. So on this pentagonal prism, you've got a pentagon here on the top, that's one base, and a congruent and parallel pentagon on the bottom. That's the other base. You need the area of one of those bases, and that's going to be what capital B is. Okay, capital P in that formula then stands for perimeter, but not just perimeter, of a base. So you would need to find the length of all of those sides now and add them together, or better yet, usually use multiplication, and come up with the perimeter of one of the bases. And this idea right here seems really, really easy, but this is the number one thing that people get wrong. H pretty obviously stands for height, but I would really like you guys to write it down and try to learn it, that what we really mean by that is height of the prism. So that of the prism is important, but that still doesn't explain it too much. This, you guys, is what you really need to know right here. That when we're talking about height of a prism, what we mean is the distance between the bases. Now again, every middle school kid thinks that a base is on the bottom and the height runs vertically. And that is absolutely the case sometimes. Like in this figure I was doodling on before here, this is the height of that prism. But if your prism runs a different direction, like maybe this weird staircase problem here, your bases are going to be this side right here, and then there's another one on the back of this figure, congruent and parallel, and the height now is the distance between those bases. It doesn't run up and down. So if you can remember the phrase distance between the bases, and in that regard, maybe the word depth would be a better word right there, I think you guys are going to do okay with height. So let's make sure we've got this formula nice and clean in our notes, and let's see it in action. I didn't write anything in the directions here, and I should have, and it should say find the surface area of each prism. So that kind of gives something away. What are we dealing with here, guys? This is a prism here because it has 2 congruent and parallel polygon bases on opposite ends of the figure. Now, what I'm hoping you guys noticed right here is that the shape of the base, and now there's a couple ways to do this, but I would think most of us would like to think the way that a middle school kid would, that the base would be on the bottom of that figure. And that's certainly sometimes the case. Now, for that to work, if that's your base, there has to be a congruent and parallel polygon on the opposite end of the figure, and sure enough, there's one right up here on the top as well. Another rectangle on the top of that. By the way, so this should work. If you couldn't tell what I was dealing with, if you took a look here, everybody, at the sizes of this box that I drew right here, I was just guessing, but 12 inches tall, 9 inches wide, 2 inches deep. I was thinking about a cereal box when I made this problem. Okay, so here we go, guys. The same 3 steps we've been using for a while now. Surface area of a prism. We start with a formula, 2 times capital B plus capital P times H. Step 2, let's fill in what we know. Surface area is 2 times, okay, capital B now, area of our base. So that's going to take a little bit of work here, guys, because remember, this is a base down here on bottom, and that's a rectangle. So capital B, I could do this off to the bottom right, top, wherever you wanted. We're looking for the area of this rectangle here, and that formula is little b times h. Base times height. So for this rectangle here, we have a base of 9, and the height of that rectangle, this piece right here, would be equal to that 2 right there. So 9 times 2 is going to get us 18 for the area of that base that we have. So 2 times 18. Okay, plus the capital P means perimeter of the base. So let me switch to red now, and the perimeter of the same shape we were just looking at. We've got 9 inches right here and another 2 inches right there. That adds up to 11. Now what I like to do with a rectangle is add up that long side and that short side. 9 plus 2 is 11, and then just multiply that by 2. The 11 times 2 is going to give us 22 for the perimeter there. Or you could do it the hard way. 9 plus 2 is 11, plus another 9 on the back gets you to 20, and another 2 over here gets you to the same 22 that we had there. And then we need h. And let me go back and hit this again. What h really means is distance between the bases. So since we drew this one with our bases on the top and the bottom, then the height is the distance, the depth of this figure between those two bases. That's going to be the 12 inches that we had right there. Now, at this point, you guys would probably go to your calculator and just type on all of this at once. Let me see here. I should have a calculator up and running here somewhere. There we go. Let me clear all this junk out. So we had 2 times, the area of our base was 18, and then we're going to hit plus. The perimeter of our base was 22. And the height of our entire prism was 10. So that should get us our answer here of 256. Now let's talk units here, guys, for the first time. Now, you might have a guess already what the units are. I don't want to guess. I want to know. So let's think about what's going on right here. For example, the 12 right here, the height, was measured in inches. That's what's going on right there. 22 was the perimeter, which we got by adding inches plus inches plus inches plus inches. So perimeter was inches as well. Inches multiplied by inches are going to get us square inches. How about over here? The 2 that we have in front isn't measuring anything. We only put a 2 there because this polygon has 2 bases. But the 18 right there represented the area of that base. This was 9 inches times 2 inches, so the area was 18 square inches. So 2 times 18 square inches is going to get you 36 square inches. And when you're adding, nothing changes. Square inches plus square inches gets you square inches for the surface area here. So that was step 3, and boom, that problem is done. Now, you can totally skip what I'm about to say, but a cool thing about this problem, guys, is that it actually could have been done totally differently. If I were to switch, I would not do this in your notes here, guys, but if I were to think about the left side and the right side of my cereal box being my bases, I should be able to do the problem this way and get the exact same answer. So again, if I were you guys, I wouldn't write this down, but let's see, can I do that in orange to match? Let's try here. Boom. Color. Yeah, let's do that. In that case, then, this would be 2 times, okay, area of the base. Now I'd be multiplying 2 times 12 to get 24 for the area there. Plus, perimeter of the base. This would be 12 plus 2, that's 14. Doubled would get me 28. And the height of this prism now, okay, the height is now going to run from left to right here, and that means that my height would be 9. Now let's see if we get the same answer of 256 doing it that way. 2 times 24, 2 times 24, there you go, plus And let's see, that was 12 and 14. We had 28 for our perimeter, and that got multiplied by 9 for the height, and we got, did I type that in wrong? 2 times 24, and then 28 times 9. No, I typed it in wrong. I think that means that I did something incorrect then. Let's see. Where did I lose it there? 24 for area of the base. Okay. Perimeter, 12 and 2, 14, 28. Height was 9. Oh, something doesn't seem right there. Maybe my first answer was wrong. Let me take a look at that one again. 9 times 2 was 18. 11, 22, height was 12. Well, I'll come back and look at that one in a second then, guys. Sorry about that. All right, let's move on to this next one right over here. Now, this problem, guys, is really, really interesting here. And out of all the problems that we're going to do, this might be the best one at showing me whether or not a person understands the vocabulary that we are talking about here within this problem. So, the first thing you guys probably want to ask yourself is, what is it that we are dealing with in this problem here? I see a three-dimensional solid, and I see some rectangles, and I see some triangles here. This is a prism because it has two congruent and parallel polygons on opposite sides of the figure, but identifying where the bases are is the most important thing. And the base is not going to be this rectangle down here on the bottom because there's no congruent and parallel rectangle up here on the top. The key to this problem, guys, is recognizing that we have a triangle here on the front of this figure that I will highlight here in blue, and then another congruent and parallel triangle right there in the back of the figure. So these two triangles are the bases, and that means that the height is actually running in this direction. Okay, so the important thing here is, guys, that we've got a base on the back and a base here on the front, and that height is running kind of front to back here. Okay, so let's get started, guys. Step number 1, surface area of a prism is equal to 2 times capital B plus capital P times H. Let's fill in what we know in step 2. 2 times, all right, guys, we need the area of one of those blue triangles. So I noticed that it's a triangle, and I also noticed this right angle that was drawn right here. And anytime you're dealing with a right triangle, you want to use those two legs, this piece and this piece right here, to be your base and height. Because remember something we talked about earlier in the chapter, base and height must always be perpendicular to each other. So this 3 centimeters right here is going to be my height, but I need this piece right over here. They gave us 5 for the hypotenuse. Well, I'm hoping you guys recognize this is a 3, 4, 5 Pythagorean triple. So without having to do the Pythagorean theorem, I know that this bottom side is 4 because I know my triples. So I usually do this in green here. The area of our base now, that would be the area of that blue triangle, would be 1/2 times its base times its height. That would be 1/2 times a base of 4 and a height of 3. So 4 times 3 is 12. Half of that is going to be 6. So the area of one base is going to be 6 square centimeters. Let's add to that now the perimeter of that same base. So let's add up your 3 sides. 3 plus 4 is going to get you 7. 7 plus 5 is going to make 12 for the perimeter. And the height of the whole prism, guys, the distance between the bases is right here. That height is going to be 10. And now for step 3, let's just put it all in together right here. That 2 times 6 is going to get you a 12. 12 times 10 is 120. Should get you 132 square centimeters for the surface area of that entire figure. And I don't think I'm going to take the time to do this problem with you. This is kind of a weird little staircase right here you might have, okay? This kind of matches the definition of a prism because of what's on the back end of this figure that you can't really see. But essentially, guys, there's this other staircase shape on the back of that, and that means that right here, what I'm highlighting in purple, are your 2 congruent and parallel polygon bases, and the height then is running horizontally between them. So what we would need to do is find both the area and the perimeter of that shape right there, and then The height between them would end up being 8 inches for that figure. I think we're going to skip that one for now because I don't want to hold you guys up too long on this section. So, okay, that's a pretty good jump for what we're going to do for surface area of prisms. Now let's start talking about cylinders. And I know this looks like a totally different formula. It's actually very closely related to what we were just talking about. Now, a cylinder, everybody, I should take a moment right here and discuss. A cylinder is just like a prism. It's got two congruent and parallel bases on opposite ends of the figure. The only difference is that in a prism, those bases have to be a polygon, any polygon, okay, as long as they're congruent and parallel. But in a cylinder, we've got circular bases on opposite ends of the figure, but they still need to be congruent and parallel to each other. So, the formula we wrote down a moment ago, you don't need to put this down again now, guys. Surface area of a prism was 2 times area of the base plus perimeter of the base times height. Well, it doesn't really look like it, but this formula here is the exact same thing. Capital B meant area of the base. Well, in a cylinder, the base is always a circle, and the formula for area of a circle is pi r squared. So the 2 times capital B becomes 2 pi r squared. The capital P here meant perimeter of the base. And in this case, perimeter of the base, well, since the base is a circle, we don't use the word perimeter, we use the word circumference. And the formula for circumference is 2 pi r. So that's the circumference, 2 pi r, multiplied by h. And that's where this formula here for surface area of a cylinder comes from. It's really the same formula as surface area of a prism. We just adapt it to accommodate for the fact that we are dealing with circular bases rather than polygon bases. Okay, it's actually a pretty easy formula to use. I tried really hard to make this problem difficult. I don't know that I did. All right, so what are we dealing with here, guys? Kind of looks like a hockey puck. It's kind of a short little cylinder here. So let's deal with our formula. Surface area of a cylinder was equal to 2 pi r squared plus 2 pi r h. So let's fill in what we know in step 2. Surface area is going to be 2 times pi. Okay, and here's where I tried to make things difficult for you guys. I didn't give you the radius. What I did give you, though, is this 24 millimeters, which is the diameter of this hockey puck right here. The radius would only make up half of that right there. That's going to be your r. So radius is going to be half of 24, which is going to be 12. So 2 times pi times 12 squared. Plus, let's keep going now. 2 times pi. This radius is going to be exactly the same as this radius, so that's still going to be 12. But now we need to know the height of this hockey puck, which would be this piece right over here. And how are we going to come up with that? I'm going to extend that radius and make a diameter going all the way across, which was 24. So now that I've used that 12, let me forget about that and say, okay, the whole bottom side is 24. There's a right angle here, and that means that we are dealing with a right triangle there in the middle of that figure. Let me kind of shade that in blue. And in that right triangle, we know the lengths of two sides. Our hypotenuse is 25. Got it. And our leg there is 24. So we could use the Pythagorean theorem to come up with h here, or we could recognize yet again that we are dealing with a Pythagorean triple, 7, 24, 25. It really does help you guys and save you a lot of time to know your Pythagorean triples. So this missing side right here is going to be 7 millimeters, and that's what's going to go in right there for h. Now, again, if I were you guys, I'd go to the calculator here. My calculator doesn't handle this quite as well. So let's see what I can come up with here for step 3. 12 squared is going to be 144 times 2 is 288 pi. That's the area of your two circles put together. And in the middle now, let me see here. 12 times 7 is 84. 84 doubled is going to be 168 pi. And we would add those two together. And let's see. 12 minus that should be 356 pi, if I'm not mistaken. Let me double check that. 288 and 168. Right? Boom, boom. Boom. All right, got us 456. Oh, I forgot to carry the 1 right there. That's kind of important. That's why you should check that stuff, kids. 456 pi. Everything was in millimeters here, so we're now talking square millimeters for the surface area of that cylinder there. Okay, there we go. And the last problem I have for you is just kind of to take you back to some of the problems that we do in a high school geometry course that you probably wouldn't have done in middle school, problems where we work backwards. So in this problem, they've told you now that you're dealing with a cylinder, they've told you the radius is 7, and they gave us the surface area. We are supposed to come up with the height. So this is why I've been hitting you guys so hard on this concept. We always start with formulas. We are dealing with a cylinder and we know surface area. So I want the formula here for surface area of a cylinder, which is 2 pi r squared plus 2 pi r h. Then in step 2, we fill in what we know. And now, this is unique to everything else we've done before today, we know the surface area is 189 pi. That's going to go right there. And that's going to equal 2 times pi. And they told us the radius of this figure is 7. So 2 times pi times 7 squared plus 2 times pi. Once again, this r is still 7, but we don't know what h is. So that's the one unknown that's in this equation so far. And now, let's work backwards to solve this, guys. I've got a 189 pi on the left. That's just going to stay there. Let's clean this up. 7 squared is 49. 49 times 2 is 98 pi. Plus 2 times 7 is going to make a 14 pi, and that's still getting multiplied by h. Now I'm trying to isolate the h here, so the first thing I would do is subtract 98 pi from both sides. Okay, these terms are going to cancel out, and 189 minus 98 should leave us, if I'm not mistaken here, with a 91 pi, and that should equal 14 pi times h. We are trying to get h by itself. Move that down a little bit, sorry. Trying to get h by itself, so the h is being multiplied by 14 pi now, so I would divide both sides by 14 pi. And what I'm hoping you guys see right away here, well, the 14s cancel on the right, the pi's cancel on the right, but most importantly, the pi's on the left cancel as well. So all we have to do here to figure out h is divide 91 by 14. Let's see here, which doesn't work out perfectly, but I don't think it's that bad. Yeah, 6.5. So I don't feel terrible about getting a nice decimal like that. So 6.5, and let's see, everything in this problem, surface area was being measured in square inches. The radius was in inches. We're trying to come up with the height. That would be in inches as well. So the height of that cylinder then would be 6.5 inches. All right, everybody, that's everything I've got for you right here in 11.4b. Once you get rolling here, these problems really do become pretty formulaic, so I really want you to hit the idea here, guys, hit this idea hard, that we write the formula down in step 1, we fill in what we know in step 3, and then we solve, fill in what we know in step 2, and we solve in step 3. And sometimes you're working forwards to find your surface area, sometimes we're working backwards to find something that's missing, like a height. Okay, let's dive into that homework on 11.4b. Let your teacher know when you guys have some questions, and good luck, everybody.